Hey everyone, my name is Sebastian, and I'm the co-VP of Engineering and Cardano Project Manager at Emergo, one of the companies behind the Cardano project. In this video, I want to talk about delegating to multiple stake pools from one wallet. So this is something you might have heard of in one of Charles's videos, where he says he wants to add a functionality so that you can delegate to multiple stake pools from one wallet, from one recovery phrase. And the reason this is good is because it adds more decentralization. Instead of delegating all your ADA to one pool, you can say, oh, I'll give some ADA to this pool and some ADA to this pool and some ADA to this pool, and it allows people to delegate to some big pools, some small pools, some pools they just like, and this kind of increases decentralization. So it's clear why everybody wants this feature. Now, the problem is that there's three main ways we could add this, and each of them has a downside. There's no easy implementation of this. And so in this video, I'm going to talk about how Cardano works now, and the three different ways we could improve and what are the downsides of each way. So before we talk about how to do delegate to multiple stake pools from one wallet, first I have to explain how wallets work in Cardano. So you might have heard of the concept of a recovery phrase, and it's also sometimes called a mnemonic, right? So when you create a wallet through when you create a wallet through Udoi or Daedalus, you'll be asked to say 15 words or 24 words, some amount of words, and this is your recovery phrase, your mnemonic. So you might wonder, how do we actually generate a wallet from this recovery phrase? Basically what we do is we take the recovery phrase and we do a one-way transformation to your root private key. Okay, and so your root private key is what is able to generate all your addresses, all your staking keys, everything comes from the root private key. However, we don't want to use the root private key directly because some systems use the same recovery phrase for multiple currencies, right? So if you imagine Trezor or Ledger, you have the same recovery phrase, and from the same recovery phrase, you get support for Cardano and Bitcoin and Ethereum and multiple other currencies. So how do we support that? Well, the way we support that in the wallet ecosystem is that we have multiple keys actually. And you go from one level to another level to another level, all the way up until you get to the address key, the key for a specific address on the blockchain. So what are these levels? Well, the first one is called a purpose. And it says, okay, what is this key going to be used for? Okay, the most common value is 44. And usually there's I won't explain, but let's say it's 44. So 44 is used for a BIP 44 wallet. And you don't really have to know what it means, but the reason we have a purpose field is because the wallet software needs to know, well, how many levels do I have? For example, in Cardano, we end up having coin type, and then account, and then change, and then address is the last one. So we have multiple different levels you go through, right? But a different cryptocurrency might have a different number of levels, depending on how the cryptocurrency works. So to know how many levels there are, first we need to have some sort of information. Okay, what is this key going to be used for? Okay, next one is coin type. So coin type says what currency this will be used for. So every cryptocurrency has a number associated with it. And if I remember correctly, Cardano is 1.815. If I remember correctly, I can look that up real quick on my screen. Yeah, so 1.815. And so different cryptocurrencies will have different numbers. So that way, different cryptocurrencies use different private keys. So if your Bitcoin wallet gets hacked, you lose the private key. It doesn't affect your other currencies, right? The next one is account. Accounts start at 0. So you can have multiple different accounts, all for the same currency, right? And this is usually how you have multiple wallets from one hardware wallet. So you have one hardware wallet, And from one hardware wallet, you get, your Cardano account 0, and your Cardano account 1, and your Cardano account 2. So although Daedalus and Yoroi do not support this feature, and I don't think any Cardano wallet does, the standard we're using, called BIP44, does have support for multiple accounts from one wallet, which would allow you to have multiple wallets from one hardware wallet. Okay? And the way we do it in Cardano is everybody just uses the account number 0. So Daedalus is always account 0, Yoroi is always account 0, Adalite is always account 0. Everybody just uses the account 0. And maybe one day we'll support multiple accounts from one hardware wallet or multiple accounts from your recovery phase, but we just don't support that yet. It was just never a really priority. Okay, the next one is change. So the way wallets work is that there's external addresses and their internal addresses. And so if you open up the Yoroi extension and you go to the receive tab, you can actually see both of these. So you'll see a tab called external and you'll see a tab called internal. Okay, and basically the way these are used is that these are addresses you share with other people. So whenever you want to receive ADA from somebody, you say, this is my address, send me ADA here. And for external addresses, you might have noticed there's a generate button, and whenever you press on the generate button, you get a new address. Okay, so the idea is you're supposed to only ever share these external addresses once per person. So every time you want to receive ADA, you generate a new address and you send this new address to a person, right? And this maximizes your privacy, because then if somebody's looking at a blockchain explorer, they can't tell, oh, this address belongs to you, because every time you've received ADA, you've always generated a new address. Now the internal address is meant for wallet software to send ADA back to yourself when needed. So for example, if you have 10 ADA and you want to send somebody 5 ADA, the way wallet software works is that it sends somebody 5 ADA and then it will send maybe like 4.8 ADA back to yourself, and that would be 0.2 in fees. Okay, oops, I made a typo here. Right, so whenever you send a transaction on Cardano, you'll send 5 ADA to somebody and you'll send some amount of ADA back to yourself. And because we don't want to send ADA back to an external address, because then it gets confusing, right? Why am I receiving 4.8 ADA to an address I sent to somebody else? Did they send me that ADA? Right, so that would be confusing to send to the external address. And so every time you send ADA, the amount that goes back to yourself goes on the internal address. And actually, if you open up Yoroi and you look at your transaction history summary, if you open up the transactions for each transaction you've ever made, you'll see something like an external base as the input, and then on the output side you'll usually see address book, which is you sent ADA to somebody else, and then you'll see something like internal. So if you ever open up the Yoroi extension and you look at your transaction history, for every transaction you'll see something that looks like this, which is sending ADA that comes from you, and you'll send it to your internal address, which is sending ADA back to yourself. Okay, so that's what the change is for. And addresses is self-evident. This is the private key for every individual address. So if I want to send ADA from this specific address, I use this key. Okay, so now that we know how BIP44 works, Cardano actually uses a modification of that for Shelley, which is CIP1852. And this is a standard that I wrote in cooperation with Matthias from MyHK, and there's input from other people. So obviously Duncan had input, the Rust team had input, a bunch of different people input in this, and I standardized that into a document called CIP1852. Named because instead of BIP44, this would become 1852. Oops. 1852. So if you're ever wondering why there's such a thing as a Byron wallet and a Shelley wallet, it's because the Shelley wallets use a different key for the purpose. So that's why you can put in the same recovery phrase and you'll get a different Byron wallet and a different Shelley wallet. And so if you go to the Yodo extension and you click restore wallet, there'll be two choices, right? Your Byron wallet, which will use BIP44, and you'll have a Shelley wallet, which uses SIP1852. Okay, so now that we have the basics of the derivation, let me talk about staking keys. So the way Cardano works for delegation is that you have a concept of a staking key. And every time you delegate your ADA, the delegation is associated with your staking key. That's why if you, again, go to the Yodo extension and look at your receive page, and there'll be base, external, and internal, right? So this is what your receive page will look like. And here there will be a bunch of addresses inside your receive page. And if you look, every address has a unique set of like last maybe like 6 or 7 letters. This may be like ABC, this is DEF. But this section here, right before the suffix, will be the same for every address, right? And that's because your base address in Cardano, what does a base address means? It means a combination of an address key and a staking key. So the way it works is that you have address, some prefix, then you have your address key in here, your payment key, and then right after that, so you have a payment key here, and this section that is the same for all your addresses, this is your staking key. And then you have a unique suffix because the suffix is a checksum, which is why it's different every time. So I encourage you to open up the Yodo extension as you're watching this video and look at your wallet. You'll notice, these internal things. You'll notice the suffixes are the same, and you'll notice, this is what a base address means. You'll appreciate all the technology that goes behind this, and I hope that makes things a lot more intuitive. But you might be wondering, okay, well, where does the staking key come from? Right? We have a staking key, but where did it come from? Well, the way we did it in Cardano is that these values here for external and internal, they actually have a numerical value, right? So external is 0 and internal is 1, if I remember correctly. Let me just double check that. Sometimes I confuse them. Yeah, so external is 0 and internal is 1. I just want to double check that for you. Okay, and we added a third one, which is 2, which is your staking key. Okay, so that's why if you ever go on a Ledger device and you restore a wallet, you'll see, for example, are you sure you want to create the account for 1852 and then 1815.0, and that will be your account. So every time you create an account on Ledger device, a Shelley wallet, you'll see, are you sure you want to create this one? And whenever you use something that uses a staking key, like you delegate your ADA, you do 1852, 1815.0, and then 20, and this will be your staking key. And so every address inside this receive page is actually the combination of 2 different paths. So the payment key that comes first will be 1852, 1815.0. In this case, I was looking at the external tab, so these will be 0, and then the address index. So this first address will be 0, the second address will be 1. And actually in Yodo, we have a verify button. So if you look in Yodo, you'll see like a verify address button. If you press that button, you'll actually see this path here, okay, which is your payment key path. And then the combination of your payment key path plus your staking key path is your base address. Okay, so now that we have a basic understanding of how Cardano works, let's talk about the 3 different proposals for how we get delegation to multiple stake pools from one wallet. All right, so let me just clear all of this quickly. So now let's go over the 3 proposals. First, I'm going to give you an outline of what they are, and then we'll go into each of them in depth. So the first one was called change equals 3. This is the name, and this comes from October of last year, and I wrote this back in October. And the second one is staking key. I don't think there's a name for this one. Address index. Let's just call it staking key address index. And again, I'll explain these what these are in more detail right after I finish listing them. The third one is called ratio delegation, or sometimes called ratio stake. And I'm gonna add a fourth one that I just want to add just to show why it doesn't really work. And this one is multi-account support. So this is, remember, I said in Cardano we always use account 0. We could say, okay, you have account 1 and account 2, and every time you want to delegate to a different stake pool, you create a new account. Okay, so first I'll start with the account solution, and I'll describe why this doesn't really work, because I think it'll explain some of the difficulties with these other solutions. So remember I said that a path was the purpose, the coin type, the account, change, and the address index. Okay, and actually this was not the full picture, and to get the full picture I'll have to explain these little apostrophes I was adding to these paths. What do these apostrophes mean? So what these apostrophes mean is how you get to the next level. Okay, oops, I'm missing an R here, purpose. And for some levels, you can only get to the next level if you have the secret key, or sometimes called a private key. Okay, but for some different ones, you can get to the next level using only the public key. Okay, and this is important because when you create a wallet in Daedalus or Yoroi, we only save the account key. Okay, we don't save the purpose key, we don't save the recovery phrase, we save the account key. Okay, and when I say we save the account key, I mean we save the secret key and we encrypt this. Okay, and then we save the public key unencrypted. Okay, so what this means is that as you can see, these levels over here don't have an apostrophe, and that means that from the account public key I can get all the change levels, and I can subsequently get all the address levels. And this is really important because you might have noticed when you have Yoroi or Daedalus running, they'll automatically refresh and find new transactions for you. Like if you send a transaction from Daedalus or Yoroi on a separate computer, it will show up on your Daedalus or Yoroi on your computer. And the way we do this is that we know which addresses are possible in your wallet without having you to type in your spending password. Okay, and the reason why is because we have the public key and we save the public key in Yoroi, and Yoroi every 20 seconds we look at the blockchain and say, okay, are there any new transactions for these addresses or any address this wallet could create in the future? And if there are, then we find the transaction for you displayed on the screen. So that's why the account key is saved unencrypted as a public key. However, the private key is encrypted. Okay, so although you can see the transactions, you cannot actually spend the ADA unless you have the secret key, right? Which is why when you want to send ADA, you need to type in your spending password. The fact that we only save the account level, and the fact that the account level has a hyphen, which is called hardened, a hardened level, is important because it means that saving only this information does not allow Yoroi to automatically detect if you add a new account. Okay, so imagine you have your Yoroi on your computer, and on your computer you have 185. Damn, I need to get better at writing these numbers. 185.2, 188.15. So imagine you have this at this wallet on your computer, on your Yoroi extension on your computer, and on a different computer you say, okay, I want to delegate to a new stake pool. So let me create a new account on a different computer. You say you create a new account, which is 1A15 1. Okay, so this is different computer, and this is your computer. Okay, so the Yoroi that is on your computer cannot automatically detect that you created a new account. And the reason why is because to detect that you created a new account, we would have had to instead store the coin type field, and we would have had to store the account field as unhardened. If we had this situation, then we could automatically detect new accounts created on different computers, but as it is, it's not possible, right? And the reason why is because, as I told you, whenever there's a hyphen, to get the next level, if there's a hyphen, you need the private key. Okay, and we don't have the private key for the coin type, and so we just can't do it. And this is problematic, right? This is not a great user experience. That it would mean that every time you want to refresh the set of accounts, so let's say you create on a different computer account 1, you want to refresh a set of accounts on your wallet, you'd have to again type in your recovery phrase to refresh. And this is like not a great user experience, right? You don't want to have to, constantly refresh and type in your recovery phrase every time. So obviously it's doable, especially from hardware wallets where you don't have to retype in the recovery phrase because it's part of your hardware wallet. But still, so it's not that great. So we want to solve this problem. So the easiest way to solve this problem, in my opinion, from a purely wallet point of view, was this change equals 3 proposal. So let me describe to you what is change equals 3. Actually, I'm going to need this. Okay, so what is this change equals 3 proposal? Let's delete all of this. Okay. Oh, software is being a bit slow. So the change equals 3 proposal starts out the same as what we have right now. Okay, so we still have purpose, we still have coin type, and we still have account. However, we add a new level here called staking key. All right, and then we go change and then address index. Okay, so if you were to do it this way, now if you want to delegate to a new stake pool on a different computer, you create a different staking key, right? So by default you would have 0, and on a different computer you would create 1. And because note that this is not hardened, right? It's not hardened, from the account public key, you can detect that a staking key was created on a different computer. You can detect that on a different computer, on a different machine, you delegate it to a second stake pool. And with this, we can automatically say, oh, hey, they delegate to a second stake pool. Let's automatically generate all the addresses for it. So that means on the Udo extension, you would have had on your receive tab some sort of drop down staking key. Right, so you had some sort of drop down menu where you pick your staking key, and based on the staking key you pick, so for example, you pick 0, then you would see, base, external, internal, and so on. I think you maybe can't see this image that well because I think my face is in the way. Let me see if I can change that. Hopefully that's better. Okay, so you'd have some sort of drop down, you pick your staking key, and once you pick your staking key, then you get a set of addresses. And those mean that from the same recovery phrase, from the same account, you can delegate to different stake pools, and whenever you want to manage your ADA, you know that all the ADA inside these addresses are always going to be delegated to stake 0. If you want to send some ADA to a different stake pool, you would send ADA from one of your addresses to the staking key 1, right? So you send ADA to yourself to a different staking key. Now this would solve, the problem I mentioned earlier, and also solve the problem that right now in Cardano, as I mentioned, every address is concatenation of 2 paths. You remember where I said every address was 1852, 1815, 0, 0, 0, for example, and 1852, 1815, 0, 0. So remember I said in Cardano, all the base addresses, they're concatenations of 2 different paths. It would have solved this problem because now every base address would instead be uniquely described by a single path, which would have been 0, 0, 0. So this path would have been a single path that contains both your staking key and your payment key, all uniquely defined in one path. So obviously this solves a lot of problems, but it's still not the best user experience, right? Because it means you have to manage multiple sets of addresses, right? You still need to have this drop down where you pick the staking key you want to use, and so it's more complex for the user, but it does solve all the problems that we had with solution number 4. Okay. So next is a different solution, the staking key address index, that says, well, okay, what's the problem with this thing I just proposed? What's the problem? The biggest problem with change equals 3. Well, the biggest problem with change equals 3 is that that's not what we use in Cardano. You remember where I said we use SIP 1852, and when I created this document, I called this change equals 2 because the staking index, remember I said the change was 0 for external, 1 for internal. Oh, my face is in the way again, sorry. Let me bring myself back up here. 1 for internal and 2 for staking. So remember I said the change derivation has 3 possible values now in Shelley: 0 external, 1 internal, 2 staking. So when I created the SIP 1852 document that describes how wallets exist in Cardano, I called this change equals 2 based off the fact that we introduced this new change derivation level. And I called this proposal change equals 3 just because it was a different proposal and I couldn't reuse 2. So that's why that's where the name comes from. Just if you're wondering, but it's a historic name. We can change the name, it doesn't really matter. Okay, so staking key address index, where does this come from? Well, it says with change equals 3, we would have to recreate all Shelley wallets again. So remember when you create your Shelley wallet last month, you had to upgrade it from a Byron wallet to a Shelley wallet, And there's still a lot of users struggling to update today. People don't understand, why do I have to upgrade? What does it mean to upgrade, and so on. And we try and, explain this to users in a simple way. But obviously explaining why it's required just took me like, I don't know, 30 minutes. I'm not sure how long this video is by now. But obviously it's not a trivial explanation to explain the full story, right? So we kind of hand wave and explain to users why it was needed. But we would need to go through that all over again if we did change equals 3, because every wall we need to change to use this new scheme, right? And that's not a great solution. We don't really want to have the users who just upgrade have to upgrade again, right? So staking key address index says, okay, what if we do something similar but don't upgrade? Okay. So what we do instead is we have, okay, every address is a payment key and a staking key. And we'll just change the last one from a 0 to a 1, and then to a 2 for the second stake pool, and a 3 for a third stake pool. Okay? And as you see, the 0 here is not hardened, right? So if you delegate to a second stake pool on your computer, then we can automatically detect, okay, new delegation was made, and we can automatically update everything. The problem with this proposal with staking key address index is that it makes this whole view of, first you pick your staking key, then you get set addresses. It kind of makes that much uglier, right? And so that was kind of the rationale for proposing this change equals 3 instead, because it kind of fixes the idea of these externals and internals, and it makes it all kind of just work out. But this idea of changing the address index for the staking key also works. And the user experience for it will probably be that inside your wallet you have a primary address, right? So instead of having it drop down, it's always 0. And then you would have some sort of like, new tab, maybe like a delegation tab. And you would not be able to send ADA from these addresses, be able to register staking pools there. So you'd say, like, okay, I want to delegate to a staking pool, like the Emergo staking pool. So you press like register, and then it says, okay, which staking pool do you want to delegate to? You say, I want to delegate 1,000 ADA. It creates a new address, this address here, but with a 1, and it puts 1,000 ADA inside this box. And if you ever want to spend ADA, you would not do it through the send screen. You would instead come to the receive page, and then you'd see you have 1,000 ADA, and there'd be like some sort of, reclaim or withdraw button. And this would send the 1,000 ADA from your second staking key back to your primary wallet. So there's a a UX complexity with this also, and we have to explain to users like, you can reclaim any time, and so on. So it's not a great UX either, but it works, right? And users will just have to get used to the fact they have a quote-unquote primary wallet and a primary delegation and these secondary delegations that exist in a separate tab. Okay. And the third solution is called ratio staking, or the ratio delegation. And this is something that actually Jormungandr used, which is when you delegate to a stake pool, right now you stake your full ADA balance, right? So how does staking work? The way staking works is, as I mentioned on the receive page, you have, a bunch of addresses, and they all have a common staking key. The way delegation works is that the amount of ADA you delegate is the sum of all of these. Right, so on the blockchain, we look at all the addresses that contain this specific staking key. And this address contains 50 ADA, and this other address contains 100 ADA. So on the blockchain, we look at all addresses that contain staking key, and we sum these up and say, okay, they're delegating 150 ADA. And so whenever you delegate your ADA in Cardano, it delegates the full balance to a pool, right? And Yorma and Gander had this concept of ratio staking, which said instead of delegating the full balance, we specify a ratio. So you then say 1/2 to pool 1, 1/2 to pool 2. Right, and you are allowed to specify any ratio you want. So you could split it 3-way with 1/3, 1/3, 1/3, or you could, split it with 1/2 to one pool and then 1/4 to two different pools. So Yorma and Gander is very flexible with this and allow you to specify different ratios. There is some complexity with this because it means that the amount of ADA you delegate to a stake pool changes every time you send or receive ADA, because that's to recalculate all the ratios. So it's more complex on the node. And the thing is that to add this feature to Haskell codebase now will require a hard fork, right? Because we would need to add a new functionality to the certificates as opposed to these other 3 potential solutions, which is done entirely in the wallet, right? It doesn't change anything on the blockchain itself. The ratio staking solution would require a hard fork, right? And so you could say, okay, well, if we want to do ratio staking, because this is a much simpler UX, you don't have, you don't even have the drop down anymore. You don't have this weird claim withdraw API. Now it's just a ratio, and it's very simple. When you delegate your ADA, you just pick a ratio, you set it, and you forget about it. But if we want to do that, we need to have a hard fork. And so if you want to do option 3, which is ratio delegation stake, the probably easiest way to do it would be, okay, well, we're doing a hard fork for Plutus anyways, and for multi-currency support. So if we're doing a hard fork anyways, let's add this functionality at the same time. And then everybody, you don't have to create a new wallet kind. You don't have to handle this new address type. You just get this new feature where you can ratio your ADA. And from a wallet point of view, this is the easiest solution, but does require a change at the protocol level. So that's it. That's the video. I want to introduce to you the top 3 recommendations right now for handling delegating to multiple stake pools from one wallet. Obviously, as I mentioned, they all have downsides. If you have a 4th solution that you think would be good, I'd love to see it. You can message me about it, or you can write a CIP, Cardano improvement proposal, about your proposed idea. But currently, these are the kind of 3 proposals that have already been floating about for the past few months. And thank you for your time.